Greetings, ICTS. I'm honored to be joining this third ICTS 2023 conference. So my name is Chong. I'll be the presenter for today's studies, which is machine learning based approach for filling gaps in streamflow data. So let's start with our introduction. So very small introduction for my studies. We study on the missing streamflow data. Streamflow is a crucial component for hydrological cycle and plays a significant role in river hydrology. The measurement of stream flow itself represents the volume of water flowing through channel over time, essential for various purposes such as flood estimation, hydraulic design, hydropower analysis, and also water resource management. However, stream flow data often suffers from missing values, which can introduce biases and uncertainties in all these analysis, which bring us to our problem statement. So we have two problem statement, main problem statement. First of all is our missing values. Streamflow datasets are often incomplete due to various reasons such as damage to measuring stations or battery depletion. So all these missing values can hinder accurate predictions and invalidate all the statistical analysis results. Therefore, having a complete streamflow dataset without any missing values is crucial. So second of all is the conventional methods. So sometimes when there's any missing values in the dataset, right, conventional methods are commonly used, such methods are arithmetic average method or coefficient of correlation. They're commonly used to estimate all these missing values. But if we compare to more modern methods such as machine learning models, they are less accurate and they'll sometimes create some uncertainty in your analysis. So which brings to our objective. So in this study, we will try to investigate different machine learning models, how they perform in estimating missing stream flow, and then we'll evaluate the performance of these estimation methods. And finally, we'll determine the most appropriate method for estimating missing stream flow data for our study area, which is Peninsula Malaysia. So for our study, we did some literature review. We did literature review on four different aspects. First of all is the factors affecting data availability, and we did some review on past studies which on all the conventional methods on how they perform in estimating missing values, and also past studies on machine learning models, and finally some past studies on comparative analysis of conventional and machine learning methods. So after our literature review, this is our methodology, and this is our study area. Our study area is at Peninsula Malaysia. We have a total of 11 stream flow stations, 8 of them located at the west coast of Peninsula Malaysia and 3 of them located at the east coast of Peninsula Malaysia. First of all, we have our homogeneity test. There's total of 4 homogeneity tests. First of all, we have our standard normal homogeneity test, our Boolean range test, petit test, and also our von-Neumann ratio test. So what does all these tests do is to determine whether our data series of each station is homogeneous. So when a data series is homogeneous, it has a constant mean over time or it follows a stationary patterns up. So the test is to ensure the data we are using is reliable. So if the data is not homogeneous, the results of the analysis may be invalid or biased up. So how this test works is we'll set a critical value which is 0.05. All these tests will produce the p-value for each data series. If the p-value is bigger than 0.05, means that we agree to the null hypothesis saying that our data series is homogeneous. Or in the other way, if our p-value is lesser than 0.05, means that our data series is non-homogeneous and our null hypothesis is rejected. Yep. Now we have our conventional methods. So we have 5 conventional methods: uh, normal ratio method, coefficient correlation method, inverse distance method, arithmetic average method, and also linear interpolation method. All these 5 methods will be used to estimate all the missing values. With all these 5 conventional methods, followed by 3 machine learning models, we have our k nearest neighbor imputation, multiple classification, and regression tree card, and also naive Bayes. And to evaluate the performance of all these estimation methods, we have 3 statistical analysis. First of all is our mean absolute error, root mean square error, and also correlation coefficient. So how is the performance of all these estimation method analyzed? First of all, we'll get our complete streamflow data set from all the streamflow stations, and we assume part of the data is to be missing. So we'll assign 3 different percentage. First of all, is our 5%, 10%, and 15%. So we assume that part of them is missing, and then we'll use all the methods, the 5 conventional methods and 3 machine learning methods to estimate all these missing values. And we'll compare all these estimated values with the original data set using the statistical test that we mentioned just now. And finally, we'll produce a overall ranking system to kind of rank which estimation method works the best and which works the least best or the worst. Yeah. And now we move to our results. So based on our results for missing values of 5%, 10%, 15%, naive Bayes is the best estimation method showing the highest score in our ranking system. So what does it mean? This means that all the estimated data from naive Bayes is the closest to the original data. So other than that, all the machine learning models such as K nearest neighbor imputation or the multiple classification and regression tree all perform far more better than conventional methods. With the multiple classification and regression tree coming second for 5% and 15% missing values, and also K nearest neighbor imputation coming second for 10% missing values. And similar to previous studies, the normal ratio is the best conventional methods, but they are still slightly worse compared to all the machine learning models. Next, it brings us to our homogeneity test. So the homogeneity of data, we categorize them into three different categories. First of all, it's useful, doubtful, and suspect. So how do we categorize them? We have four different types of homogeneity tests. We have petite NST, BRT, and PNR tests. So when three or more tests, three or four, because we have four tests, three or more tests state that our data series is homogeneous, means that our data series is useful. If two out of four state that it's homogeneous, then we call it doubtful. And finally, if three or all of the tests say that our data series is non-homogeneous, then we'll categorize it as suspect. So based on our results, 4 out of 11 stations are considered to be useful, which is Sungai Kurau, Sungai Arau, Sungai Muda, and also Sungai Klang. Means that all these are useful. We can use this data series considered to be homogeneous. And the rest of the 7 stations are doubtful. They indicate there may be some inhomogeneity in the data, but they can still be used for further analysis as long as the data are carefully processed. In addition, only one homogeneity test was found to be rejected by majority of stations, which is our VNR test. Since VNR test assumes that the time series consider random distribution, thus the results show that streamflow data for all our stations, they are not randomly distributed. And finally, we come to the conclusion of our presentation. So first of all, we successfully estimated all the missing streamflow data in Peninsular Malaysia using various estimation methods. We use 5 conventional methods and 3 machine learning methods. All the data are coming from 11 streamflow stations, 8 from the west coast of Peninsular Malaysia and 3 from east coast Peninsular Malaysia. And the performance of the total 8 estimation methods are all evaluated using measures like RMSE, MAE, and R. Naive Bayes ranked the highest based on the lowest RMSE and MAE, and the highest R value, and is regarded as the best method, or the 8 estimation method that we studied. And the best conventional method is the normal ratio method. Future recommendations, we might recommend an increased neighboring station data because we only have 11, and also to test estimation methods with different data sets and explore other machine learning models for improved accuracy. And that's all for my presentation. Thank you very much. And these are the reference for the presentation today. Thank you.